Now, the thing is, all the prices that are in our target were collected in the 1970s. Now, I wasn't around back then, but I am told the 70s was a glorious time to be alive. The thing I know for sure, however, is that $1 in 1970 was worth much, much more than $1 today. In fact, inflation is a horrific thing for anybody with savings. And to buy a house today, you need many, many more dollars than you do in the 1970s. So, given that we want to get a dollar price estimate that's a bit closer to today's values than 1970s values, let's make an adjustment to the estimates that our model is spitting out. The only question is how do we get a more realistic price out of our little valuation tool? For starters, let's take a look at what the median price in our dataset is as it stands currently. And we can see this if I pull up NumPy's median function, so np.median, and I supply the target values in the Boston underscore dataset. So Boston underscore dataset.target inside these parentheses for the median function will calculate the median value of a property in our dataset. And what we see is that in 1970, the median value was $21,200. This is where we were at in 1970 in Boston. But what about today? If I Google Zillow Boston home values, I'm brought to this page here. So this is on Zillow.com, which actually gives us a median estimate for home prices in Boston as of today. And what we see here is that today, the median home value is approximately $583,000. More than $500,000. And that's a combination of inflation as well as increases in the real price of homes. Now, as a challenge, can you write the Python code that converts the estimated price from our model, which is in 1970s log prices, to today's dollar values? You're going to have to convert the estimate itself, the upper bound and the lower bound, to today's prices. And once you've converted it, round the values to the nearest $1,000. I'll give you a few seconds to pause the video, and then I'll show you my approach to solving this problem. Ready? Here it goes. So the first thing I'm going to do is I'm going to say Zillow underscore median underscore price is equal to 583.3. This is the price in thousands that I saw on Zillow's website for the median price in Boston at the time of recording. The next thing I'm going to do is I'm going to calculate some sort of scale factor. The number I'm going to have to multiply my 21.2 by in order to get a realistic value for today. So this is going to be a scale underscore factor, which is equal to, well, it's going to be equal to 583 divided by 21.2, right? So Zillow underscore median underscore price divided by np dot median parentheses Boston underscore dataset dot target. Let's take a look at what the scale factor is equal to. So scale underscore factor, shift enter. We now see that the dollar prices should be multiplied by 27.5. Okay, so that was step one. Now let me call my function. So my function will give me a log estimate. It will give me an upper price and a lower price, and it will give me some confidence interval. those of course are going to get their values from our function get underscore log underscore estimate. And then I'm going to calculate, I don't know, a price estimate for a mansion with 9 rooms and maybe students underscore per underscore classroom is going to be equal to, say, 15. Next underscore to underscore river is going to be equal to false. And high underscore confidence is going to be equal to, I don't know, false. Let's vary it up a bit. Okay, so now I've got my scale factor calculated, and I've got values that I'm going to calculate for my estimate, my upper and lower bounds, and my confidence interval. Let me hit Shift Enter, make sure this works. And it does, no errors. Now what I'll do is I'll convert to today's dollars. So the dollar estimate is going to be equal to, first off, reversing the log transformation. So np.e times log underscore estimate, then times 1000 because our dollars are in thousands, and then times, well, you guessed it, the scale underscore factor that we've calculated above. This gives us a dollar estimate for today. Let's take a look at what this one is actually. So dollar underscore estimate, Shift Enter. Here's our unrounded value for a mansion that is not next to the river and has a pretty small class size, 15 students. That estimate in today's dollars is approximately 826,000. Now we just need to round it, right? I'm going to add another comment. Say round the dollar values to nearest 1,000, and I'll create another variable that's going to hold on to the rounded estimate. So I'll say rounded underscore estimate is going to be equal to the return value from some sort of rounding function. I'm going to use numpy's around function. So np.around parentheses dollar underscore estimate, comma, and I have to say I want to round to the nearest 1,000. So I'm going to say -3. Let's take a look at what this output actually reads. So rounded underscore est, Shift Enter, and here we see it's 826,000. So this is a rounded value. Brilliant. Now all that's left to do is do the same thing for the upper value and the lower value. I can first off copy this line of code, paste it twice, change my variable name, so say high and then low, and we're transforming upper and we're transforming lower, and then we're also going to round the upper and the lower values. So it's going to be rounded high and rounded low for dollar underscore high and dollar underscore low. Let me print all of this out with f strings. So print parentheses f single quotes, the estimated property value is curly braces rounded underscore est full stop, Shift Enter. That works, except I've got a typo, estimated property value. Let's add another print statement. Print f single quotes at curly braces conf % confidence, the valuation range is, final print statement, f single quotes USD space curly braces rounded underscore low at the lower end to USD curly braces rounded underscore high at the high end, full stop. Okay, so that was just a lot of typing, but now we can look at our output nicely worded using the variables that we've defined earlier inside some f strings. Let's take another look at the output for this cell. Brilliant. That works beautifully. Now tell you what, let's add all of this to a function. Let's create another function called getEstimate and make this function do all the conversion as well as call this function here to actually get the estimate. So I'm going to define a function, df get underscore dollar underscore estimate parentheses colon. And then inside the body of this function, I'm going to put all the code that we've written above. So all of this up to here will go inside of the function. So copy this, I'm going to paste it in here, and then you'll see it's not indented. So I'm going to have to indent it so it's actually part of this function. And I can do that by selecting all the lines and hitting Tab on my keyboard. Now what we want is we want this function here to actually take, again, like the 4 arguments that we're passing through to our other function call. We can call the first one rm, we can call the second one pt ratio, we can call the third one chaz and set that equal to false by default. And then the last argument, we can call it large underscore range and set that equal to true by default. And this means that in our nested function call right here to get log estimate, we can pass through these parameters. So this won't be number 9, this will be rm. This won't be students per classroom equals 15. This will be pt ratio. This won't be next to river equals false, but next to river equals, say, chaz. And this won't be high confidence equals false, but it'll be high confidence equals large range. So I hope that you can see how using these different arguments works. For these two, I've used an argument by keyword. So next to river is the keyword, chaz is the value, which we'll get from this function call. And for this argument, high confidence is the keyword and large range is the value. Rm and pt ratio are just the values because I'm passing these arguments by position, not by keyword. So this is argument number 1, this is argument number 2. If I didn't want to pass the arguments by position, I could use a keyword as well. So I could say students underscore per underscore classroom is equal to pt ratio. And that's because this is the keyword that we've defined in our signature for getLogEstimate. All right, so we've got our function, we've got our way of getting the log estimates, we've got our way of converting the log estimates to today's dollars, and we've got the part where we're rounding those values, and then where we're showing some sort of output to whoever's calling the function. Let's try all of this out for good measure. So get underscore dollar underscore estimate for a small apartment with, say, rm equal to 2 and a terrible school with 200 kids. So pt ratio is equal to 200. But on the upside, this apartment will be next to the river. So chaz is equal to true. Before I hit Shift Enter on the cell, I'm going to make sure that I have hit Shift Enter on this cell beforehand. And now I know that my function will be recognized as I do the same here. The estimated property value is 0. And at 95% confidence, the valuation range is between 0 at the lower end and $1,000 at the high end. Why is that? And that's because the parameters that we've supplied here are completely unrealistic, right? This number in particular, you never have 200 kids per teacher in the local school. A more realistic number is something like, say, 30, which will then give us a more realistic estimate. The same problem we might face if we have, say, 0 rooms in the apartment, which of course is nonsense. in this case, even for a property with 0 rooms, which is impossible, we get a price estimate. Now, there's 2 ways that you can avoid this kind of situation, right? First off, you might have to inform people what getDollarEstimate does and what these values actually represent before they start just calling this function. And the second thing that you can do is you can reject giving an estimate if these values are unrealistic. Let me show you how you could do that, for example. So coming up here, and at the very top of the function, we could have an expression like if rm is smaller than 1, colon, print, single quotes, that is unrealistic. Full stop. Try again. Yeah? And then, still within this if block, as you can tell by the indentation, we return. So, as soon as this return instruction is hit, none of these following lines of code will be executed. I'm going to hit Shift Enter, refresh the cell, and then I'm going to try to run this code again. See what we get. Our function now does not provide an estimate when the inputs for the rooms are completely unreasonable. If you wanted to check 2 things, say we wanted to make sure that this value here is not smaller than 1 as well, right? Then what we could do is we could come up here to our if statement, and then we could use a logical OR to check 2 separate conditions. So if rm is smaller than 1, or if pt ratio is smaller than 1, then print this line and return from the function. In other words, one of the things that you can do to make sure that your functions aren't being completely abused is to actually check the values that are being supplied when they're being called. So if I hit Shift Enter now, and I change this line to something reasonable, like say 6 rooms, and I try to change this line here from PT ratio of 30 to PT ratio of minus 60, then I'll get the same message. Okay, so strategy 1 was checking for inputs. But better yet, let's add some sort of description about what this function does so that the person using it can pull up, say, the quick documentation. If I press Shift Enter on this now, I can see the signature. I can see it says rm, pt ratio, chas is equal to false, so I see the default values. And hitting that plus sign, I don't see anything else. What I would like to see, though, is something called a docstring. The docstring should give us a description of our function, what it does, what its inputs are, and more or less like how to use it. Let me show you how we can add this to our getDollarEstimate function. At the very, very top, we can put in 3 double quotes. And as you can see, there's already 6 double quotes here because Jupyter Notebook inserted the closing 3 double quotes. In other words, you have 3 double quotes at the beginning and you have 3 double quotes at the end. The first 3 double quotes mark the beginning of the docstring. The last 3 quotes mark the end of the docstring. And whatever we put in between will appear in the quick documentation. Check it out. Estimate the price of a property in Boston. Full stop. Shift Enter. And then Shift Tab will now show this description in the quick documentation. One of the good things to do when you're writing function that you want other people to use is to include a little bit of information about what the function does and also what the keyword arguments are. After all, if we do that on np.around and press the little plus sign, we do indeed see some information on the parameters that this function takes, a, decimals, and out. Yeah, so we can see a little description here, and we can use this function the way it was intended to. Let's do the same thing for our function. So if I come in here and say keyword arguments colon rm hyphen hyphen number of rooms in the property, and then PT ratio hyphen hyphen number of students per teacher in the classroom for the school in the area. Chaz hyphen hyphen true if the property is next to the river, false otherwise. Large underscore range hyphen hyphen true for a 95% prediction interval, false for a 68% interval. Brilliant. Adding this description here for our keyword arguments and hitting Shift Enter allows us to see what these arguments are and get a little description in the quick documentation when we hit Shift Enter and take a look. Brilliant. All right, we're almost made it to the end. The last thing I want to show you is how we can package what is in this Jupyter notebook here as a Python module. If we look at our ML projects folder here, a Python module is a file that ends in .py. To create one of these files, what we can do is we can upload a .py file to this folder, or alternatively, we can go to New Text File and create this py file in Jupyter Notebook directly. I personally quite like the Atom text editor for writing Python code and editing it. Of course, you can use other text editors as well to create these py files, but Atom is definitely a good one. To save you the trouble of installing a text editor, I'll show you quickly how you can do this in Jupyter Notebook directly. First off, let's rename this file. Let's rename it as valuation.py. Or better yet, let's name it as Boston_valuation.py. Click OK. And now we're going to copy some of our Python code and paste it into this empty.py file. Let's copy the imports, for example. Put those here. Let's copy the cell where we're gathering the data. Put this here. Coming down, let's copy this cell here with our indices and our property stats variable. Copy it and put it here. I don't really need this comment, so I'm going to delete it. Scroll down, add a few more lines. Go back to our notebook, scroll down a little more, copy the part where we're running our regression, put it in here, come back, copy the function where we're doing our log estimate, of course, add it to our .py file, and then come down here where we've got our scale factor, copy those two lines, go into our py file, scroll to the top in this case, and I'm going to add it below our crime and ZN indices. So I'm going to paste it in here. And then finally, I'm going to grab all the code in this cell here, copy it, and paste it at the very end of my .py file. All that's left to do now is File, Save, and now in my projects folder I have a Boston_valuation.py module that contains all my Python code, which I can now use in any of the Python notebooks in this projects folder. Check it out. In the valuation tool, I can come down and I can say import Boston underscore valuation as val. And I can call a function from this module, namely our getDollarEstimate function, with val dot get underscore dollar underscore estimate parentheses 6, 12, and true. Hitting Shift Enter, I get a price estimate. All my arguments here are passed by position, and this function call here comes from the module, right? It comes from the module that I've just imported. This one here comes from the notebook. This one here comes from our Boston underscore valuation module. Now, of course, this is a lot more clear if I open my multivariable regression notebook and try to do the same thing. Under the notebook imports, I can import Boston underscore valuation as val. And if I hit Shift Enter here, scroll to the very bottom and say val dot get dollar underscore estimate parentheses 8, 15, false, I will get an output from my getDollarEstimate function from inside my .py file. Fantastic. So we've covered quite a few things again in this lesson. It's been a review of a lot of the concepts that we've talked about so far, but we've also learned a lot of new things. On the Python front, we've learned how to create functions with optional arguments, how to call these functions with the arguments where we supply the values by position and by keyword. We've learned about how to make the quick documentation show up for functions that we ourselves have written using the docstrings. We've covered how you might exit a function if you don't like the inputs that it's getting. And we've covered how to use if-else blocks to check for a condition or even two different conditions. So again, congratulations for making it all the way through this. I know the learning curve is getting steeper, and I look forward to seeing you in the next modules. Take care.